Hello dear students, all of you welcome to Vidyan classes. It is the first lecture on function or mapping. Today we will discuss definition of a function, domain, codomain and range of the function. Lastly, we will discuss types of functions. First definition of a function. What is the definition of function or mapping? The relation capital R from capital A to capital B is called the function if first condition the relation capital R from A to B. A and B are two non-empty sets. A and B are two non-empty sets. The relation is defined when A and B are two non-empty sets. The relation capital R from A to B is called the function if domain of R, that is dom R. Dom R means domain of R is equal to set A. Second condition, this is first condition, XY order pair belongs to R, XZ order pair belongs to R, XY order pair belongs to R, XZ order pair belongs to R, that implies Y is equal to Z. Clear? The relation capital R from A to B is called the function if domain of R is equal to set A. Second condition, XY order pair belongs to R, XZ order pair belongs to R, that implies Y equal to Z. It is A set, it is B set, R is the relation from A to B. From this definition, it is clear that one many relation is not a function. XY order pair belongs to R, XZ order pair belongs to R. That means one many relation is not a function. If Y equal to Z, then it will be a function. Dom of R is equal to set A. Second condition, XY order pair belongs to R, XZ order pair belongs to R. That implies Y equal to Z. From this definition, it is clear that one many relation is not a function. It is a one many relation. It will be function if Y equal to Z. One many relation is not a function. Or we can say the relation capital R from A to B is called function. The relation capital R from A to B is called function if first condition dom R is equal to set A. Domain of R is equal to set A. Second condition, all first members of the order pairs in R. All first members of the order pairs in R are different to each other. XY order pair belongs to R. XZ order pair belongs to R. X repeated twice. The relation R contains XY order pair and XZ order pair. R will be a function if Y equal to Z. Clear? The second condition implies all first members of the order pairs in R are different to each other. Clear? Clear? Okay. Note down. Next, example of function or mapping. Let capital A be the set containing 1, 2, 3 and capital B be the set containing 4 and 5. R is the relation such that A to B, which implies R subset or equal to across B. Relation is the subset of Cartesian product. Every subset of a Cartesian product represents the relation. This expression implies R is the relation from A to B. First example, let R1 is the set of 1, 4, 3, 5. R1 is a relation from A to B. R varies as R is the subset of A across B. R1 is the subset of A across B. Is not a function. Since DOM R1 is the set of 1, 3 is not equal to A set. A contains 1, 2, 3. Domain of R1 is not equal to A set. So R1 is not a function. R represent the relation R is a function if domain of R is equal to set A. Second condition, all first members of the order pairs in R are different to each other. So R1 is not a function. Example 2. R2 be the relation from A to B. 1, 4, 2, 5, 3, 4. 1, 4. R2 is the set containing 1, 4 order pair, 2, 5 order pair and 3, 4 order pair. Is a function. Since DOM R2 is the set of, what is domain? Collection of all first members of the order pairs 1, 2, 3 is equal to A set. The first condition is satisfied. Second condition, all first members of the order pairs in R2 are different to each other. It is the first condition. It is the second condition. Two conditions are satisfied. The relation will be a function if these two conditions are satisfied. Since R2 satisfies two conditions, R2 represent the function. Clear? Example 3. R3 be the relation from A to B. 1, 4 order pair, 2, 4 order pair, 3, 5 order pair, 2, 5 order pair. R3 is a relation from A to B. 1, 4 order pair, 2, 4 order pair, 3, 5 order pair and 2, 5 order pair is not a function. Since all first members of the order pairs in R2 are not different to each other, as 2 repeats twice. R3 contains 1, 4, 2, 4, 3, 5 and 2 5 is not a function. Since all first members of the order pairs in R2 are not different to each other, as 2 repeats twice. 2, 4 order pair, 2, 5 order pair. The first member, that is 2, repeats twice. Clear? In the above discussion, in example 1, example 2, example 3, note all functions are relations, but the converse is not true always. But the converse is not true always. All functions are relations, but the converse is not true always. It may or may not be a function. All functions are relations, but all relations may or may not be a function. Here in R1 it is a relation but not a function. R2 is a relation, also function. R3 is a relation but not a function. So all functions are relations, but the converse is not true always. Clear? Clear? Okay, note down. Next, second definition of a function. What is the second definition of a function? If the graph of the curve y is equal to fx meets y axis at 2 points, then the curve is not a function. Otherwise, it is a function. If the graph of the curve, that is y equal to fx, meets y-axis at 2 points, then the curve is not a function. Otherwise, it is a function. If the graph meets y-axis at 2 points, then it is not a function. Otherwise, it is a function. Or if the graph of the curve y equal to fx meets the line parallel to y-axis, that is x equal to k belongs to R. If the graph of the curve, that is y equal to fx, meets the line parallel to y-axis, that is x equal to k. X equal to k is the line parallel to y-axis. K belongs to R. Is not a, if the graph of the curve, that is y equal to fx, meets the line parallel to y-axis, that is x equal to k belongs to R, then the curve is not a function. Otherwise, it is a function. Clear? If the graph of the curve is y equal to fx, meet y-axis at 2 points, then the curve is not a function, otherwise it is a function. Similarly, if the graph of the curve y equal to fx meets the line parallel to y-axis, that is x equal to k is the line parallel to y-axis, then the curve is not a function. Otherwise, it is a function. For example, it is the graph of y is equal to y square is equal to minus 4a x minus a. For x is equal to 0, y is equal to plus minus 2a. It is 0 to a and it is 0 minus 2a. It meets y-axis at 2 points. It is a curve of parabola. Y square is equal to minus 4a x minus a. Is not a function. Is y square is equal to minus 4x minus is not a function. Since it meets at 2 points, that is a and b. For x equal to 0, there is 2 values of y. It is a one many relation, not a function. Example 2. Y is equal to s cube. It is the graph of y is equal to s cube. It is the graph of y is equal to s cube. It does not meet y-axis at 2 points. So it is a function. It is a function. The graph of the curve meets y-axis at 2 points, then the curve is not a function. Since the parabola meets y-axis at 2 points, the parabola is not a function. Y square is minus 4a x minus a is not a function. It is the graph of y is equal to s cube, which does not meet y-axis at 2 points. So it is a function. It is also meets the line x is equal to, suppose it is 3, k is equal to 3. Here the graph of the curve, that is parabola, meets the line parallel to y-axis at 2 points. For x equal to 3, the parabola meets at 2 points, that is C and D. The graph of the curve meets y-axis at 2 points, then the curve is not a function. Or we can say, if the graph of the curve meets the line parallel to y-axis, this line x equal to 3 is parallel to y-axis, and the curve meets x equal to 3 at 2 points, that is C and D. So it is not a function. Similarly, example 3, it is the equation of a parabola, ellipse, s square by a square plus y square by b square is equal to 1. It meets the y-axis at 2 points. It is origin. Clear? Here x is equal to, suppose, minus 2. The ellipse meets y-axis at 2 points, that is A and B. The ellipse also meets the line x equal to minus 2 at 2 points, which is parallel to y-axis. Is not a function. Is not a function. Clear? It is not a function since it meets y-axis at 2 points, or the line, or it meets the line which is parallel to y-axis at 2 points. Similarly, in case of ellipse, it meets y-axis at 2 points. Also, it meets the line parallel to y-axis at 2 points. C, it is D. So, it is not a function. Another example. It is the graph of y is equal to x mod. Y is equal to mod of x. It is the graph of y is equal to mod of x. Is a function since it does not meet y-axis at 2 points, or the line parallel to y-axis. It does not meet the line parallel to y-axis at 2 points. So it is a function. Is a function. Y is equal to x mod is a function. S square by a square plus y square b square is equal to 1 is not a function since it meets y-axis at 2 points or the line parallel to y-axis at 2 points. Y is equal to sq is a function since it does not meet y-axis at 2 points or the line parallel to y-axis at 2 points. It is also not a function since it meets the y-axis at 2 points or the line parallel to y-axis at 2 points. Clear? So it is not a function, but y is equal to x mod is a function, y is equal to sq is a function. Clear? Okay, note down. Next, domain, codomain and range of the function. What is domain, codomain and range of the function? Let f so that a to b is a function. F so that a to b is a function. Implies this. Domain of f, which is same as df, is equal to a. Domain of f is equal to df is equal to a, or df, domain of f, is the collection of x so that xy order pair belongs to f, where f is a function from a to b. Here x is the object and y is the image. F operates on x, gives y, y is the image and x is the object or pre-image. Whenever f operates on x, gives y. Clear? Domain of f is the set of all first members of the order pairs in f. It is the first member, it is the second member, which is same as a, is equal to a set. Second point, codomain of f is equal to b set. If f is a function from a to b, then b is equal to the codomain of f. Third point, range of f, which is same as collection of y so that xy order pair belongs to f, or we can say set of all images. X is the object, y is the image of x when f operates on x. Set of all images is called the range of f, or we can say set of all second members of the order pairs in f is called the range. It is the second member or image. Set of all images is called the range. Clear? Set of all second members of the order pairs in f is called range, or set of all images is called the range. Question: find domain, codomain and range of the function shown in figure. F is a function A to B. It contains 1, 2, 3. B contains 6, 7, 8 and 9. Seven is the image of 1, 7 is the image of 2, and 3 is the image, 9 is the image of 3. F so that A to B, F is equal to set of 1, 7, 2, 7, 3, 9 is a function. It satisfies the two conditions of a function. All first members of the order pairs are different to each other, and the collection of first members, that is the domain of f, is equal to a set. Here the domain is dash. Set of 1, 2, 3 which is equal to a. All first members of the order pairs in f are different to each other, so it is a function. First, domain of f. What is a domain? Domain of f is equal to a set, or we can say collection of all first members of the order pairs. What are the first members? 1, 2, 3 which is equal to a set. Second, it is the solution starts from this. Domain of f is set of 1, 2, 3. Codomain of f is equal to B set. What is B set? Set of 6, 7, 8, 9. Third condition, the range of f. Range of f. What is range? Set of all images. 7 is the image of 1, 7 is the image of 2, 9 is the image of 3, the set of all images, or set of all second members of the order pairs in F, which is equal to set of 7 and 9. Find the domain, codomain and the range of the function shown in the figure. F is a function from A to B. Solution starts f such that a to b, f is the set of 1 7 2 7 3 3 9 is a function since it satisfies two conditions of a function. Domain of f means that is a set. A set means set of 1 2 3. Codomain of f means b set. B set means set of 6 7 8 9. And range of f means set of all images, that is 7 and 9. Set of 7 and 9. Clear? Clear? Okay, note down. Next, types of functions or mappings. All functions can be divided into two groups. All functions can be divided in two groups. That is, onto functions and into functions. All functions can be divided into groups. That is, onto functions and into functions. Onto function can be divided into groups. Onto functions can be divided into two groups. 1 1 onto functions. Many 1 onto functions. Similarly, into functions can be divided into groups. One into functions. Many 1 into functions. Here, all functions can be divided into two groups. That is, onto functions and into functions. Onto function can be divided into groups, that is 1 1 onto functions, many 1 onto functions. Into function can be divided into groups, that is 1 1 into functions and many 1 into functions. Clear? Note down. Note down. Next, 1 1 onto. One onto function. Many 1 onto function. What is 1 1 onto function and many 1 onto function? Let f be a function from a to b. A contains 1 2 3. B contains 4 5 6. 1 corresponds to 4. 2 correspond to 5, 3 correspond to 6. If so that a to b is a function, f is the set of 4 is the image of 1, 5 is the image of 2, 6 is the image of 3. So f contains 1 4 order pair, 2 5 order pair and 3 6 order pair. Is a 1 1 onto function. Is a 1 1 onto function. From this example, we can find out the definition of onto function. What is many one onto function? F is a function from A to B. A contains 1, 2, 3. Suppose B contains 4, 5. 1 corresponds to 4. 2 corresponds to 4. And 3 corresponds to 5. F so that F is a function so that A to B. F is equal to set of 4 is the image of 1, 4 is the image of 2, 5 is the image of 3. F contains 1 4 order pair, 2 4 order pair and 3 5 order pair. Is a many one onto function. It is called the 1 1 onto function and it is called the many one onto function. From these two figures, we conclude the definition of onto function. Here, range of f, which is shortly written as RNGF, that means range of f or R of f. What is range? Range of the function, the set of all second members of the order pairs in f is called range. The second members are 4, 5, 6, which is same as B set. Clear? In 1 1 onto function, the range of f is equal to B set. In many one onto function, here range of f, which is same as RNGF, which is same as RF. That is range of f. Range means collection of all second members of the order pairs in F. What are the second members? 4, 5. Set of 4, 5 is same as B. It is a 1 1 onto function, it is a many one onto function. From these two examples, we can define the onto function. Definition: of onto, or onto is also called surjective function. Definition of onto or surjective function. Here range of f is equal to b. Here range of f also b. A function f so that a to b is equal to a function f so that a to b is equal to onto or surjective if range of f which is same as RNGF, range of f which is equal to RF. Range of f is a function from a to b is said to be onto or surjective if range of f is equal to b set. Here range of f is b set. Here range of f is b set. Or what is 4, 5 and 6? 4 is the image of 1, 5 is the image of 2, 6 is the image of 3. Every element in B is the image of any element in A. Here 4 is the image of 1, 4 is the image of 2, 5 is the image of 3. So every element in B is the image of any element in A. It is 1 1. It is many 1. It is 1 1. It is many 1. In one word, we can say at least one element. F so that A to B. F so that A to B is called onto or surjective if every element in B is the image of at least an element in A. Or we can say F so that A to B is equal to onto or surjective function if every element in B, if every element in B, if every element in B is the image of at least an element every element of B is the image of at least an element in capital A. Clear? It is the second definition. Of onto. Second definition of onto. It is the first definition. It is the second definition of onto. Clear? F so that A to B is called onto or surjective function if every element in B is the image of at least an element in A. 4 is the image of 1, 5 is the image of 2, 6 is the image of 3. So every element in B is the image of any element in A. Here 4 is the image of 1, 4 is the image of 2, 5 is the image of 3. So every element in B is the image of an element in A. Here it is 1 1. Here it is the main one. In one word, we can say at least one element in A. F such that A to B is called onto or surjective function if every element in B, every element in B is the image of at least an element in A. Third definition. Of onto or surjective. X is any element in A, Y is the image of X, F is the function from A to B, it is B set, F such that A to B is said to be an onto or surjective if for every Y belongs to B, for every Y belongs to B, there exists at least an element X belongs to A such that Y is equal to Fx. Third definition of onto function. Onto function. F operates on X gives Y. Then Y is equal to Fx. When F operates on X gives Y. Y is the image of X. Y is the image of X. X is the object, Y is the image. Or X is called the pre-image of F. When F operates on X gives Y. F such that A to B is said to be an onto or surjective if for every Y belongs to B there exists at least an element X. For every Y belongs to B there exists at least an element X belongs to A such that Y equal to Fx. Clear? It is the first definition, it is the second definition, it is the third definition. Most important this and this. A function f such that A to B is called onto or surjective if range of f is equal to Rng, that means range of f which is same as R of f, that is equal to B. Here f is a function from A to B is said to be an onto or surjective function if for every Y in B there exists at least an element X belongs to A so that Y is equal to Fx. Clear? Clear? Okay, note down. Next, 1 into function and many one into function. What is 1 into function? Consider an example. F is a function from A to B. Set A contains 1, 2, 3. Set B contains B 4, 5, 6 and 7. 1 corresponds to 4, 2 correspond to 5, 3 correspond to 7. F so that A to B is a function. F is the collection of 1 4 odd pair, 2 5 odd pair, 3 7 odd pair. Is a one into function. F so that A to B is a 1 into function. What is many 1 into function? F is a function from A to B. A is the set of 1, 2, 3. B is the set of 4, 5, 6, 7, 8 and 9. 1 corresponds to 5, 2 corresponds to 7 and 3 corresponds to 7. F is a function from A to B. F is the collection of 1 5 odd pair, 2 7 odd pair and 3 7 odd pair. Is a many 1 into function. It is a 1 into function since there exists 1-to-1 correspondence between the elements of capital A and capital B. It is a many 1 into function since there exist many elements of A correspond to one element in B. What is the range of the function in 1 into function? What is the range? And what is the range of the function in many 1 into function? What is the range? Here range of f is equal to R and G f, which is same as Rf. Range is the collection of all second members of the order pairs. That is equal to 4, 5 and 7, which is the subset of capital B. Capital B contains 4, 5, 6, 7. Range of F is the collection of 4, 5, 7. Clear? That means range of F is the proper subset of B. That is range Rf is the proper subset of B. That means Rf or Rf subset of B but not equal to B. Rf is the proper subset of B. That means range of F is a subset of B. Range of F not equal to B. Clear? In many 1 into function, here range of F is equal to Rf is equal to collection of 5, 7. Second member of the order of pairs. Or set up all images. Second member of the order of pairs or set up all images is called the range, which is also subset of B. That is RF subset of B not equal to B. RF is the proper subset of B. Clear? From these two examples, we can define the definition of into function. Definition of into function. It is a one into function, it is a many one into function. In general, if range of f is the proper subset of B, then the function is said to be into. A function f such that A to B is said to be into function a function f such that A to B is said to be into function if range of f is the proper subset of B and RF is not equal to B. A function f such that A to B is said to be into function if range of f is subset of B not equal to B. Clear? Clear? Okay. Here 6 is not the image of any element in A. Here 6 is not the image of any element. 4 is not the image of any element in A. 8 is not the image of any element in A. 9 is not the element of is not the image of any element in A. Difference between onto and into functions. Difference between onto and into function. First, onto function. A function f such that A to B is equal onto or subjective if every element in B is the image. Every element in B is the image of at least means one or more. In one it is one, in many one it is many two or more. At least in B is the image of at least an element in capital A. A function f so that a to b is called onto or surjective if every element in B is the image of at least an element in A. Into function. A function f so that a to b is called into if at least an element in B is not the image of any element in A. A function f so that what is onto function? A function f so that a to b is called onto or surjective if every element in B is the image of at least an element in A. What is into function? A function f so that a to b is called into if at least an element in B is not the image of at least an element in B is not the image of any element in A. Clear? Here 6 is not the image of any element in A. Here 4 is not the image of any element in A. 6 is not the image of any element in A. 8 is not the image of any element in A. 9 is not the image of any element in A. In general, here it is 1 is not the image. Here 4 elements are not the image of any element in A. In general, we can say at least one element in B, at least one element or at least an element or one element in B is not the image of any element in A. Clear? It is the difference between onto and into functions. Difference between onto and into functions. Clear? In onto function, every element in B must be used. But in into function, at least one element will be left out. That means any one of the elements in B is not the image of an element in A. Clear? Clear? Next, 1 or injective function. What is the definition of 1 or injective function? Definition: a function f so that a to b is 1 or injective if different elements of capital A, that is the domain of F have different images in capital B. Capital B means A is the domain set, B is the codomain of A is the domain of F, B is the codomain of F. Codomain of F. A function capital F so that A to B is 1 1 or injective if different elements of capital A, that means the domain of F, have different images in capital B, that is the codomain of F. Clear? A function F so that A to B is 1 1 or injective if different elements of capital A have different images in capital B, where A is the domain of F and B is the codomain of B. Example, let capital A be the set of ABC and capital B is the set of X, Y, Z, B. The function F so that A to B is defined by a function F so that A to B is defined by F is equal to set of AX, BY, CZ. Diagrammatically it is represented by F is a function. F is a function from A to B. A contains ABC, B contains X, Y, Z, B. A corresponds to X, B corresponds to Y, C corresponds to Z. X is the image of A, Y is the image of B, Z is the image of C. Clear? X is the image of A, Y is the image of B, Z is the image of C. Here, different elements of capital A have different images in capital B. Here different elements of capital A have different images in capital B. X is the image of A, Y is the image of B, and Z is the image of C. Different elements of capital A have different images in B. Therefore, the function f such that A to B defined by f is equal to set of Ax order pair, By order pair, Cz order pair is one or injective. Clear? By the definition, F satisfies different elements in A has different images in B, so the function defined by is injective. A function f so that A to B is 1 or injective if different elements of capital A have different images in capital B. Here the function defined by satisfies the definition of 1 or injective. So f is the set of Ax order pair, By order pair, Cz order pair is 1 or injective. Second definition of injective or 1 function. Second definition of injective or 1 function. What is the second definition? A function f so that A to B is one or injective if every x1 x2 belongs to A, that is the domain of F. Here A is the domain of F. Belongs to A. Fx1 is equal to Fx2. That implies x1 is equal to x2. What is the second definition? A function f so that A to B is 1 or injective if every x1 x2 belongs to capital A, fx1 is equal to fx2, that implies x1 is equal to x2, or x1 not equal to x2, that implies fx1 is equal to not equal to fx2. Fx1 equal to fx2, that implies x1 equal to x2, implies the function f is 1 or injective, or we can say x1 not equal to x2, that implies fx1 not equal to fx2. Diagrammatically it can be represented as f is a function from a to b. x1 it is fx1, x2 fx2. F operates on x1 gives fx1 which is equal to y1. It is y2. Different objects have different images or same objects have same images. Images are same. fx1 is the image of x1. F is the mirror. It is the object. It is the image. x1 is the object. fx1 is the mirror image of f. x2 the object. fx2 is the mirror image of f, where f represent the function or mirror. fx1 is called the mirror image of x1. fx2 is the mirror image of x2. Simple, we can say x1 is the object and fx1 is the image when f operates on x1. x2 is the object, fx2 is the image when f operates on x2. Objects are same, images are same. First condition. Objects are different, images are different is the second condition. This condition or this condition is the definition of 1-1 or injective function. Clear? Clear? Example of 1-1 or injective function. So that the function f, so that real set to real set fx is equal to 3x plus 5 is injective. It can be proved by the second definition. Solution: f such that real set to real set fx is equal to 3x plus 5. For every x1, x2 belongs to R, that is domain set, domain of f, that is as fx1 is equal to fx2, which implies as fx is equal to 3x plus 5. fx1 means 3x1 plus 5. fx2 is equal to 3x2 plus 5. That implies 3x1 is equal to 3x2. Clear? fx is equal to 3x plus 5, fx1 is equal to 3x1 plus 5, fx2 is equal to 3x2 plus 5. By the definition, for every x1, x2 belongs to R, fx1 is equal to fx2, fx1 is equal to 3x1 plus 5, fx2 is equal to 3x2 plus 5. 5 cancel, implies this 3x1 is equal to 3x2, which implies 3 cancel, x1 is equal to x2. Now we have for every x1, x2 belongs to R, that is domain set, domain of f, fx1 is equal to fx2 implies x1 is equal to x2. Therefore, the function defined by is 1 1, that is injective, that is or injective. Clear? Clear? Okay. Next, bijective function. Bijective function. What is a bijective function? Definition: a function if such that a to b is bijective if f is both injective and surjective. That means injective means 1 1, surjective means on 2. Injective means 1 1, surjective means on 2. A function f such that a to b is bijective if f is both injective and surjective. That means 1 1 and on 2. Example: let capital A be the set of 1 2 3 4 and the capital B is the set of A, B, C, D. A function f so that A to B is defined by f is the set of 1A, 2B, 3D and 4C. Let capital A is the set of 1 2 3 4 and capital B is the set containing A B C D. A function f so that A to B is defined by f is the set of 1A order pair, 2B order pair, 3D order pair and 4C order pair. Figuratively it can be represented as 1 2 3 4 A, B, C and D. 1 correspond to A, 2 correspond to B, 3 correspond to D, 4 correspond to C. A is the image of 1, B is the image of 2, C is the image of 4 and D is the image of 3. That means every element in A have different images in B. Satisfies the definition of 1 1. Here every element of capital A means 1 2 3 4. Here every element of capital A have different images in capital B. F is the function from A to B. Here every element of capital A have different images in B. It is the definition of 1 1. First definition of 1. So F is 1 1. Clear? Second, on 2. What is on 2? A function f so that A to B is said to be onto if range of f is equal to B, that means codomain set. Again, range of f. Range means collection of all second members. Here the second members are A, B, C and D. Again range of F, that is Rf, which is equal to set of all second members, that is A, B, C, D, which is equal to B. What is B? Is the codomain set. The function is defined. It is the domain set, domain of F, and it is the codomain of F. If range of F is equal to B, that means codomain set. Codomain of F. It is the definition of onto. Implies this F is onto. F is 1 1 and F is onto, therefore the function is bijective. A function f so that A to B is bijective if f is both injective and surjective. Therefore the function defined by the function f defined by EG by Z. Clear? Therefore the function defined by EG by ZT, since it is 1 1 and onto. Clear? It is the function. Clear? Okay, note down. Next question. Elements of mathematics, CHAC. Example 9. So that the function f so that n to n, that means natural number to natural number, defined by fx equal to x is not bijective. The function f so that n to n, natural number set of natural numbers to set of natural numbers, defined by by fx is equal to 2x. F is a function defined fx equal to x, and f is the function from set of a natural number to natural number. We have to show it is not bijective. That means f is bijective means 1 1 and on 2. Test for injective or 1 1. For every x1, x2 belongs to n, that means the domain of f. Fx1 is equal to fx2. That implies fx is equal to x, fx1 is equal to 2x1, fx is equal to x, fx2 is equal to 2x2. That implies x1 is equal to x2. Now we have for every x1, x2 belongs to capital N, that means domain of f, fx1 is equal to fx2, that implies x1 is equal to x2. It is the definition of 1 1. The function defined by satisfies the definition of 1 1. Therefore, f is injective. That means 1 1. Test for surjective. Test for surjective. What is surjective function? For every y belongs to capital B, if there exists at least an element in capital A, so that fx equal to y, where f is the function defined from A to B. It is the first definition, and the second definition is given by if range of f is equal to codomain set, then the function is onto or surjective. Surjective or onto, injective or 1 1. One one or injective. It is the set of a natural number. It is the set of a natural number 1, 2, 3, 4 dot dot. 1, 2, 3, 4, 5 dot dot. F is the function defined from set of a natural number to natural number. Fx is equal to 2x. For x is equal to 1, fx is f1 is equal to 2, f2 is equal to 4, f3 is equal to 6, f1 is equal to 2. That means 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 6, and so on. Clear? Fx is equal to x, f1 is equal to 2, f2 is equal to 4, f3 is equal to 6. Clear? F such that n to n, f is equal to set of 1, 2, 2, 4, 3, 6, dot dot. Clear? Imply this range of f, range of f, that is equal to Rf is the collection of, range means collection of second members, that is 2, 4, 6 dot dot this. It is the set of even integers which is not equal to codomain set, that is n. Here the codomain set is n. It is the domain of f, it is the codomain of f. If range of f is equal to codomain, then the function is said to be onto. Therefore, f is not onto. F is injective but not surjective. That is surjective. The function defined by is injective but not surjective. Clear? Here the range is not equal to codomain set. The codomain is codomain of f is n. F is not onto. That is not surjective. F is not surjective or onto. The function defined by is injective but not surjective. Therefore, f such that n to n fx is equal to 2x is not bijective. Hence proved. Clear? Okay. Next. Inverse function. Inverse function. What is inverse function? Definition. If a function f so that a to b is bijective, then f to the power minus 1 so that then the function f to the power minus 1 so that b to a. If a function f so that a to b is bijective, then the function f to the minus 1 so that b to a is called inverse of f so that a2. If a function f so that a to b is bijective, then the function f to the minus 1 so that b to a is called inverse of f, which is defined from a to b. So from the definition it is clear that every bijective function has the inverse, where F inverse is the collection of yx order pair such that xy order pair belongs to F. Or we can say, or F is the function from A to B. If F contains xy order pair, F is the function defined from A to B. And F inverse is the function from B to A. If F contains xy order pair, then F inverse contains yx order pair. Yx order pair belongs to F inverse, xy order pair belongs to F. Clear? F is the function from A to B. And F inverse is the function from B to A. If F contains xy order pair, F inverse contains yx order pair. Clear? Xy order pair belongs to A cross B, yx order pair belongs to B cross A. Where since F inverse is the function from B to A, F inverse contains yx order pair, xy order pair belongs to F. Clear? Or we can say yx order pair, the elements of F inverse is yx order pair. Yx order pair belongs to F inverse, implies and implies by xy order pair belongs to F. Clear? Xy order pair belongs to F, yx order pair belongs to, or we can say yx order pair belongs to F inverse. F inverse operates on y. F inverse operates on y gives x. Implies and implies by F operates on x gives y. Fx is equal to y. Where F is bijective. Where F such that A to B is bijective. Clear? If a function f such that A to B is bijective, then the function f to the minus 1 such that B to A is called inverse of f. From the definition it is clear that, note, from the definition of inverse function, from the definition of inverse function, it is clear that every bijective function has the inverse. If the function is bijective, then its inverse is exist. That is, if f is bijective, then inverse f inverse is exist. From the definition of inverse function, it is clear that every bijective function has the inverse. That is, if f is bijective, then f inverse is exist. Clear? No doubt? Next, example 16, elements of mathematics, page number 22. The question given by, let f such that R to R, that means real set to real set, be defined by fx is equal to 3x plus 5, so that f is bijective. Find f inverse 1 and f inverse 0, so that the function is bijective. That means bijective means 1 1 and on 2. That means injective and surjective. First we have to show f is bijective. If it is bijective, then its inverse is exist. Solution: the function f so that real set to real set defined by fx is equal to 3x plus 5. To show f is bijective. To show f is bijective. Implied and implied by f is 1 1 and on 2. That is injective and surjective. Test for 1 1. Test for 1 1. That is injective. Here, first we have to test the function is 1 1 or not. For each x1, x2 belongs to A means R. That means domain of F. Fx is equal to fx1 is equal to fx2, which implies yes, fx is equal to 3x plus 5, fx1 is equal to 3x1 plus 5 is equal to 3x2 plus 5, which implies yes, 5 cancel, 3x1 is equal to 3x2, which implies yes, 3 cancel, x1 is equal to x2. Now we have for each x1 x2 belongs to R set, that is domain, fx1 is equal to fx2, that implies x1 is equal to x2. It is the definition of injective or 1 1. Therefore, f is injective or 1 1 or 1 1. Clear? Test for surjective. Surjective or onto. Y is equal to fx is equal to 3x plus 5, which implies yes, 3x is equal to y minus of 5, which implies x is equal to y minus of 5 divided by 1. Y is fx, which is equal to 3x plus 5. 3x is equal to y minus 5. X equal to y minus 5 divided by 3. By the definition of surjective, for every y belongs to R, for every y belongs to R, what is R? Codomain. That is B, codomain of F. It is the domain of F, it is the codomain of F. For every y belongs to capital A, R, that is real set, there exists an element, in R, that is the domain of F, so that Fx is equal to, it is the definition of a surjective. For every y belongs to B, B means R, there exists an element in R, that is domain of F, so that Fx is, we have to show Fx equal to y. What is Fx? What is the value of x? X is equal to y minus of 5 divided by 3, which is same as Fx or y is equal to 3x plus 5. F of x is replaced by y minus 5 divided by 3. 3 into y minus 5 divided by 3 plus 5. 3 cancel, which is equal to y minus 5 plus 5. 5 cancel, that is equal to y. For every y belongs to R, that is B, codomain set of F, there exists an element in R, domain of F, so that Fx is equal to y. Now we have for every y belongs to R, there exists an element in R, that means domain of F, so that Fx is equal to y. It is the definition of a surjective or onto. Therefore, F is surjective or onto. Therefore, F is surjective or onto. Now we have F is injective. Since F is injective and surjective, since F is injective and surjective, implies F is bijective. What is bijective function? The function which is injective and surjective is called bijective. In first part we have proved f is injective. In second part we proved it is surjective. Since f is injective and surjective implies f is bijective. The first part is proved. Now we have to find out f inverse y. Since f is bijective implies f inverse is exists. Every bijective function is invertible. Since f is bijective, f inverse is exists. X is equal to equation 1 implies x is equal to y minus 5 divided by 3. It is 1. F is bijective. Y is equal to fx implies and implies by x is equal to f inverse y. X is equal to this, which implies x is equal to f inverse y. F inverse y is equal to y minus 5 divided by 3, which implies f inverse x. F inverse y is equal to y minus 5 divided by 3. Replacing x for y, f inverse x is equal to x minus 5 divided by 3. It is the inverse of, inverse of y is equal to fx, which is equal to 3x plus 5. The inverse is exists. F inverse x is equal to x minus 5 divided by 3. Clear? Okay. Next we have to find out F inverse 1. It is R, F is the function defined from real set to real set. It is F inverse. Clear? F inverse fx is equal to f inverse x is equal to x minus 5 divided by 3. It is f inverse. F is the function from R to R, f inverse is the function from this side R to R, f inverse x is equal to this. Clear? F inverse x, it is x, it is y. F operates on x gives y, f inverse operates on x, fx is equal to y, implied and implied by f inverse y is equal to x. F inverse x is equal to x minus 5 divided by 3. F inverse 1. Find the value of f inverse 1. That is equal to 1 minus 5 divided by 3. That is equal to minus 4 by 3. F inverse 0. Putting 0 for x, that is equal to 0 minus 5 divided by 3, which is equal to minus 5 by 3. Answer. Clear? F is the function real set to real set. F inverse is the function from this side that is the real set to real set. F inverse x is obtained, x minus 5 divided by 3. Putting 1 for x, it gives minus 4 by 3. Putting 0 for x, it gives minus 5 by 3. Clear? No doubt?